Welcome to the SIP Fundamentals. Unveiling the basics of session initiation protocol. Hey there, tech enthusiasts and communication aficionados. Today, we are embarking on a journey into the heart of modern communication protocols as we unravel the basic operations of SIP, Session Initiation Protocol. If you have ever wondered about the magic behind how voice and video calls seamlessly traverse the vast landscape of the internet, SIP is the unsung hero making it happen. In this video, we are breaking down the complexities into bite sized nuggets of knowledge, perfect for beginners and anyone curious about the foundational workings of SIP. What is the agenda? Understanding the basic SIP operations. We'll start by demystifying what SIP is and why it's crucial player in the world of communication. Think of it as the digital handshake that makes conversation happen. Call setup and termination. I have wondered how that call connects so quickly. We are going to explore how SIP manages the setup and tear down of voice and video calls, making it all seem like magic in the coming more sessions. So for that, you'll have to stay tuned. And also user location and registration, SIP has a way of keeping track of users and their devices across the vast digital landscape. So find out how SIP manages user location and registration for efficient communication. Then we have signaling and media planes. Delve into the nitty-gritty of how SIP handles the signaling and media aspects of communication, ensuring your messages and multimedia content reach their destination flawlessly. So by the end of this video, you will grasp the basics of operations of SIP, that is Session Initiation Protocol. So for this, you just need to share. If you like this, then you just need to share, and don't forget to subscribe for more tech insights. So let's learn this protocol together. So here in this figure, you can see Alice calls Bob. Alice is calling to Bob. So, using SIP identity, a type of uniform resource identifier URI, a uniform resource identifier URI called SIP URI. It has a similar form of an email address that contains username and a host name. So, in this case, it will be mostly SIP message, SIP colon bob at the rate biloxy.com, where biloxy.com is the domain of Bob's SIP service provider. Alice has a SIP URI of alice at the rate atlanta.com. Alice at the rate atlanta.com. Okay, Alice might have typed in Bob's URI, or perhaps clicked on a hyperlink or an entry in an address book. So SIP also provides a secure URI, that is Uniform Resource Identifier, called as SIP's URI. So example would be bob at biloxy.com. Here bob at biloxy.com. So a call made to a SIP's URI guarantees that secure encrypted transport, namely TLS, is used to carry all the SIP messages from a caller to a callee domain. Okay, from there the request is sent securely to the callee, but with security mechanisms that depend on the policy of the domain of the callee. Okay. So the security mechanisms also depends on the policy of this particular collie. Alice is the caller here and Bob is the collie. The one who initiates the call is the caller. The one to who the call is initiated, like for Bob, Bob is a collie here. Okay, Alice is caller, Bob is collie. So SIP is based on an HTTP like request or response transaction model. You can see invite F1, it is sent to the atlanta.com proxy, which is the proxy of Alice, and this invite is forwarded further to the another proxy server, that is now here it is shown as biloxy.com proxy. Okay, as soon as this invite is forwarded to the another server, the 100 trying is sent back to the caller, right? So as soon as this invite F2 is sent further to the Bob's SIP phone, okay, so the 100 trying is or forwarded back to the atlanta.com proxy. Okay, so SIP is based on a on HTTP like request or response transaction model. Each transaction consists of a request that invokes a particular method or function on the server and at least one response. So in this example, the transaction begins with the Alice soft phone sending an invite request addressed to Bob's SIP URI. Invite is an example of SIP method that specifies the action that the requester, the here requester is the Alice, wants the server Bob to take. The invite request contains a number of header fields. Header fields are named attributes. These, whatever the header fields or the information elements this invite contains, are called as attributes. Okay, so header fields are named as attributes that provide additional information about this invite message or any other message in this figure. Okay, so all these messages contains its own header fields, which contains its own attributes, each attribute conveying important information about that message. So the ones present in an invite include a unique identifier for a call, the destination address, Alice address, and information about the type of session that Alice wishes to establish with Bob. The invite, here we have the message F1 in figure might look like this, might look like this. So the invite message F1 we discussed in the previous slide, that might look like this. So this is the first line, right? So the first line uh, of the text encoded message, you can see, contains the method of type invite. So the lines that follows are a list of header fields. You can see these are the list of header fields or attributes briefly described here below. Okay, so this via contains the address. You can see that it contains the address at which Alice is expecting to receive responses to this request, this invite request. So it also contains a branch parameter. You can see here there is a branch parameter that identifies this particular transaction. Okay, this particular transaction it identifies. So here we have from. It also contains a display name Alice. Alice is a display name, right? So it contains display name Alice and a SIP or SIP's URI, Alice atlanta.com @atlanta.com. So this is SIP URI, Uniform Resource Identifier, that indicate the originator of the request. So this is indicating what? Who the one who has originated the request, that is Alice. This is indicating the originator of the request. This header field also has a tag parameter containing a random string. It contains a random string that was added to the URI by the soft phone. So Alice soft phone adds this random number or the random string to the URI by a soft phone. It is used for the identification purposes. It is used for identification purposes. Then we have call ID. Here call ID contains a globally unique identifier for this call. Call ID we can identify globally. This is unique globally. Okay. So this call ID is generated by a combination of this random string. It is generated by the combination of random string and the soft phone's host name or IP address. Soft phone's host name, that is Alice, or whatever the IP address of this Alice is. So it is the combination of call ID is the combination of host name or the IP address of the host name and the um, what do we say? This is random string or the IP address. So the combination of the two tag we have from, and the combination of this two tag we have here, combination of the two tag, from tag and call ID completely defines a peer-to-peer SIP relationship between Alice and Bob is referred to as a dialogue. Okay, the combination of two tag, from tag and this call ID, it defines a peer-to-peer SIP relationship between Alice and Bob, and it is referred to as one complete dialogue. Now we have C sequence or command sequence that contains integer and a method name. Here the method name is invite, right? So if it was a prac C sequence, then there will be integer plus here the method name as prac, provisional acknowledgement. So we'll go through all those messages in detail as we move on with this session, further like upcoming sessions. So but for now we will be discussing about invite and 200 OK in detail. So we have command sequence. So this is a number. This number is incremented for each new request within a dialogue. Okay, within a dialogue. What all contains a dialogue? To, from, and call ID. The combination of these three is referred to one dialogue. Okay. So this is C sequence, command sequence. It has one integer followed by a method name. So it is incremented. It is incremented for each new request within a dialogue, and is a traditional sequence number. So this contact contains a SIP or SIP's URI that represents a direct route to contact Alice. Using this contact, uh, the callee can directly contact to this Alice, the caller. Okay, this is the direct route to contact Alice. Usually composed of a username at a fully qualified domain name. While a fully qualified domain name is preferred, many end systems do not have registered domain names. So IP addresses are permitted in this contact. So while the via header, we have here the via header field tells the other elements where to send the response, the contact header field tells the other elements where to send future requests. Okay, so we have max forwards here. This serves to limit the number of hops a request can make on the way to its destination. So it consists of an integer that is decremented by 1 at each hop. For example, invite is triggered from Alice to the proxy server, the next proxy server. So there 70, here we have 70, that gets reduced by 69. So from there, that proxy server, one more hop is taken to the another proxy server. Okay, so there again the hop is reduced to 68. Likewise, the hops gets reduced, it keeps on getting reduced as many hops the message takes to reach to the callee. So it is decremented by 1 at each hop. Then we have here content type. So this contains a description of the message body. Okay, so content length, this contains an octet byte count of the message body. So this type of the media, codec, the details of the session, like whatever I said, like type of media, codec or sampling rate, hmm, are not described using SIP. Rather, the body of the SIP message contains a description of the session encoded in some other protocol format called as session description protocol. So if you want to learn more about the session description protocol, please write it down in the comment section or request me in the comment section. I will definitely make awesome videos for session description protocol, using which you can just learn and dive into the world of technology, and you will love learning it. So will I. So since the soft phones does not know the location of Bob, okay, the soft phone, the Alice soft phone does not know the location of Bob or the SIP server in the biloxy.com, okay, domain, the soft phone sends the invite to the SIP server that serves Alice domain, atlanta.com. The address of the atlanta.com SIP server could have been configured in Alice soft phone, or it could have been discovered by DHCP, for example. Okay, the server of Alice. This could have been configured by the configured in Alice soft phone, or it can be discovered easily by using DHCP. So atlanta.com SIP server is a type of SIP server known as proxy server. This atlanta.com, that is also known as proxy server. A proxy server receives a SIP request and forwards them on behalf of the requester, that is Alice. We have Alice, okay. So in this example, the proxy server receives the invite request and sends 100 trying response back to the, we have see 100 trying response back to the requester. So 100 trying response indicates that the invite has been received and that the proxy is working on her behalf to route the invite to the destination. So responses in SIP use a 3-digit code followed by a descriptive to, from, call ID, C sequence and branch parameter in the via as the invite, which allows Alice's phone to correlate this response to the sent invite. The atlanta.com proxy server locates the proxy server at biloxy.com, possibly by performing a particular type of DNS, that is domain name service lookup, to find the SIP server that serves the biloxy.com domain. So as a result, it obtains the IP address of biloxy.com proxy server and forwards or proxies the invite request there. Before forwarding the request, the atlanta.com proxy server adds an additional via header. One more via header is added here, field value that contains its own address. Here the via header is added, which contains its biloxy.com address. Okay, the invite already contains Alice address in the first via, right? It adds the first via in which the Alice header is there, as here one more via header is added in which the biloxy.com's own address is added. So biloxy.com proxy server receives the invite and responds with a 100 trying response back to the atlanta.com proxy server. to indicate that it has received the invite and is processing the request. The proxy server consults a database generically called a location service that contains the current IP address of Bob. The biloxy.com proxy server adds another via header now. It adds the another via header field value with its own address to the invite and proxies it to the Bob SIP phone. Bob SIP phone receives the invite and alerts the Bob to the incoming call from the Alice so that the Bob can decide whether to answer the call, that is Bob's phone rings. That is 180 ringing, F6, 180 ringing, 180 ringing. Bob's SIP phone indicates this 180 ringing response, which is routed back through the two proxies in the reverse direction. Each proxy uses a via header field to determine where to send the response and removes its own addresses. So for example, here 180 ringing is routed back to the via header. So biloxy.com had added its own address on the via header, right? So it receives and it checks for its own address and it just removes the via header from that particular message and then forwards it to the next via header. So here atlanta.com address will be added in via header. Atlanta.com proxy will remove its own address and for it will forward it to the Alice's soft phone. So when Alice soft phone receives the 180 ringing response, it passes this information to Alice, perhaps using an audio ringback tone or by displaying a message on Alice's screen. In this example, Bob decides to answer the call. So when he picks up the handset, his SIP phone sends a 200 OK. Okay, his SIP phone sends a 200 OK response to indicate that the call has been answered. So the 200 OK contains message body with the SDP media description of the type of session that Bob is willing to establish with Alice. So as a result, there is two-phase exchange of SDP messages. Alice sent one to Bob and Bob sent one back to Alice. This two-phase exchange provides basic negotiation capabilities and is based on a simple offer or answer model of SDP exchange. If Bob did not wish to answer the call or was busy on another call, an error response would have been sent instead of this 200 OK, which would have resulted in no media session being established. So the 200 OK message F9 in the figure as we saw, so that might look like this as Bob sends it out. Okay. Here you can see the first line of the response code 200 OK. This contains the response code 200 and the reason phrase OK. So the remaining lines contains the header fields. The via, to, from, call ID, C sequence header fields are copied from the invite request itself. Okay. So there are three via header field values, one added by Alice. Here you can see we have three, right? Via header fields. So one added by Alice, SIP phone, one added by Atlanta.com proxy, one added by biloxy.com proxy. So this is the biloxy.com, this is the Atlanta.com, plus this is the Alice phone, Alice SIP phone header field. So Bob's SIP phone has added a tag parameter. Uh, Bob SIP phone, what it has added the tag parameter again to the to header field. Here you can see. So this tag will be incorporated by both endpoints into the dialog and will be included in all future requests and responses in this call. So A contact header field contains a URI at which Bob can directly reach at his SIP phone. So the content type, here we have this content type and content length refer to the message body that contains Bob's HTTP media session information. So here the content length refer to the message body that contains Bob's HTTP media information, right? So in addition to DNS and location service lookups shown in the example whatever we discussed. So in this example, proxy servers can make flexible routing decisions, okay? Flexible routing decisions to decide where to send a request. So for example, if Bob SIP's phone returned a 486 busy here response to the biloxy.com server, this could the um, proxy server could proxy the invite this invite to Bob's voicemail server. Okay, so the proxy server can also send invite to a number of the locations at the same time. This type of parallel search is known as forking. Okay, so this simply means if, for example, the Bob's phone is busy right now and Alice is sending invite, so it can simply send a voicemail. This server can make it happen that it will send a voicemail to the Bob's phone, or multiple, if this number is like logged in, or this particular device, this particular URI, so this account has been logged in into the multiple devices, so it will be doing like parallel search, right? This can send the invite to the number of locations at the same time. So this type is nothing but a parallel search, which is known as forking. Okay, so in this case, 200 OK is routed back through the two proxies. This is Biloxi and Atlanta, and is received by Alice softphone, which then stops the ringback tone and indicates that the call has been like answered by sending acknowledgement. So finally, Alice's softphone sends an acknowledgement message ACK to Bob's SIP phone to confirm the reception of the final response 200 OK. So in this example, the acknowledgement is sent directly from Alice softphone to the Bob SIP phone by bypassing the two proxies. This occurs because the endpoints have learned each other's address from the contact header fields through the invite or 200 OK exchange, so which was not known when the initial invite was sent. So the lookups performed by the two proxies are no longer needed, so that the proxies drop out of the call flow. So this completes the invite 200 acknowledgement three-way handshake used to establish a SIP initiation protocol, or the SIP sessions. Okay, so Alice and Bob's media session has now begun, and they send media packets using the format to which they agreed in the exchange of SDP. So in general, the end-to-end media packets take a different path from this SIP signaling messages. So during the session, either Alice or Bob may decide to change the characteristics of the media sessions. So this is accomplished by sending re-invite containing a new media description. This re-invite references the existing dialogue, so that the other party knows that it is to modify an existing session instead of re-establishing a new session. So the other party sends 200 OK to accept the change. The requester responds to the 200 OK with an acknowledgement. So if the other party does not accept the change, he sends an error response such as 488 not acceptable here. So if Alice wants to switch from voice call to the video call, it will send the re-invite. And if Bob wants to accept the video call, it will send 200 OK, and Alice will acknowledge the 200 OK with ACK. If Bob is not willing, for example, he is not in the situation, or he simply doesn't want to do a video call, so he will simply send 488. That means not acceptable here. I don't want to make a video call now. So it will send 488 error code. Okay, which also receives an acknowledgement. So however, the failure of the re-invite does not cause the existing call to fail. So even the Bob accepts the acknowledgement or it does not accept the acknowledgement, instead if it sends the error code also, it is not going to affect the existing session, that is the voice call which has been established between the Alice and Bob. Okay, so the session continues using the previously negotiated characteristics. So at the end of the call, Bob disconnects. Now Bob is disconnecting. Bob is disconnecting, that is hangs up. The Bob hangs up first and generates bye message. So bye message is sent from Bob to Alice, right? So the bye is routed directly to the Alice's soft phone. Again bypassing these two proxies. So Alice confirms receipt of the buy with the 200 OK response, which terminates the session and the buy transaction. So no ACK is sent, and ACK is only sent in response to a response uh, to an invite request. So it is simply send acknowledgement if it is only a invite request. For buy 200 OK, when it sends, it does not receive any acknowledgement for it, or it does not send any acknowledgement for the buys 200 OK response. Okay, so the reasons for this special handling for invite will be discussing in the upcoming sessions, but relate to the reliability mechanisms in SIP. The length of the time it can take for ringing phone to be answered and forking. For this reason, request handling in SIP is often classified as either invite or non-invite, referring to all other methods beside invite. Okay, so in some cases it may be useful for proxies in the SIP signaling path to see all the messaging between endpoints for the duration of the session. For example, if the biloxy.com server, here we have the biloxy.com proxy server, wish to remain in the SIP messaging path beyond the initial invite, it would add to the invite a required routing header field known as record route, that contained a uniform resource identifier resolving to the host name or IP address of the proxy. So this information would be received by both Bob's SIP phone, and due to the record route header field being passed in the 200 OK, okay, this 200 OK to the by, sorry, 200 OK to the Alice's soft phone and stored for the duration of the dialogue, the biloxy.com proxy server would then receive and proxy the ACK, this acknowledgement, buy and 200 OK to the buy. So each proxy can independently decide to receive subsequent messages, and those messages will pass through all proxies that elect to receive it. So this capability is frequently used for proxies that are providing mid-call features. So registration is another common operation in SIP. Registration is one way that the biloxy.com server, the server can learn the current location of Bob. Upon initialization and at periodic intervals, Bob's SIP phone can register to a server in the biloxy.com domain known as SIP registrar. Okay, so the register messages associate Bob's SIP or SIP's URI, that is SIP Bob at the rate biloxy.com, with the machine info which he is currently logged, like conveyed as SIP or SIP's URI in the contact header field. So the registrar writes this association, also called a binding, to a database, so called the location service, where it can be used by proxy in the biloxy.com domain. Often, a registrar server for a domain is co-located with the proxy for that domain. So it is an important concept that the distinction between types of SIP servers is logical, not physical. So Bob is not limited to registering from a single device. For example, both his SIP phone at home and the one is in the office could send registrations. This information is stored together in the location service and allows this proxy to perform various types of searches to locate Bob. So similarly, more than one user can be registered on a single device at the same time. So location service is just an abstract concept. It generally contains information that allows a proxy to input a URI and receive a set of zero or more URIs that tell the proxy where to send the request. Registrations are one way to create this information, but not the only way. So arbitrary mapping functions can be configured at the discretion of the administrator. So finally, it is important to note that in SIP, registration is used for routing incoming sessions request and has no role in authorizing outgoing requests. Authorization and authentication are handled in SIP either on a request by request basis with a challenge or response mechanism, or by using a lower layer scheme. So we will discuss about additional operations in SIP such as querying for the capabilities of the SIP server or client, using options, or canceling a pending using request using cancel. So in the upcoming session, we will be learning about structure of SIP protocol. So thank you so much for tuning in. Your tech journey, like, it will continue from here. Amazing viewers, thank you so much for taking the time to watch my video on Learn with Sumi. I hope you enjoyed diving into the fundamental operations of session initiation protocol as much as I enjoyed bringing it to you. So subscribe for more if you haven't already. Make sure to hit that subscribe button and turn on notifications, like and share. Connect with me on the email given here, learn with Sumi. Sorry, it was like little mistake at the rate google dot gmail.com. Okay, so connect with me using this Gmail. Stay updated. Join if you want to join the tech conversation. You can join with me in the comment section, and keep exploring, keep learning, and keep innovating.